So hey guys, we're here at the CABDA show in San Diego, and I'm with Jude Monica, and we're at the Magura booth. Jude is the technical service manager for North America, and we're just going to kind of talk about some of the new developments with Magura, and then from there maybe go into just some of the details of like how to use the brakes better, how do they work, and how the dynamics, especially as they relate to electric bikes, because that's what we sell primarily. And I mean, you guys are really well positioned to do more with electric bikes, as there's oftentimes a bit of this crossover with the weight. I mean, because you guys actually have a lot of brakes for motocross and that sort of thing, which is not so common with bike manufacturers, but you guys are in that unique position. So
we've got roots in motorcycles. Since 1926, we've been on BMW motorcycles.
Yeah.
And like dirt bikes, we've got Husqvarna spec right now. So yeah, we're used to dealing with forces and weights that are far beyond the bicycle.
Right.
So it kind of prepped us really for the e-bike. The e-bike has a bit more weight, a little bit more force required to slow these weights down, and also you get up to speed quicker and more repetitively than a mountain bike. You know, you get up to that 20 miles per hour regularly.
Right.
On a mountain bike, you get up to 10 or 12 maybe.
Right. Sometimes even 28 with the speed bikes.
Exactly.
Right.
Exactly. So, yeah, the braking is a bit more important and more higher requirements. So, the e-bike is an awesome tool in every configuration, cargo to mountain bike. I love them.
Yeah.
So, and fortunately, our brakes are super tested on brake dynamometer, a motorcycle standard brake dynamometers, always has been. So, we've always made our rotors a little thicker than the competition too. Early on in the 2000, we were criticized for having too thick of rotors. Well, in the end, it works out because
I never complain when the rotors are thick, so I will say that.
You know, the
on
weight
e-bike.
weenies were more concerned.
Yeah.
We're not so concerned about it these days. Even in the mountain bike, I think it's less of a concern. So, yeah, we run a 2 millimeter thick rotor. Always have. Things like our calipers are typically larger than the competition, and that's for a reason. That's a very vital component at heat control. It's a heat sink, if you will. So your rotor is your first line of defense for heat. It's your radiator. That takes a lot of heat. The pad condition takes a lot of heat. The caliper takes a lot of heat. We also make a one-piece caliper. That's all we make. So under heavy loads, heavy usage, it will have less tendency to clam. Okay. It is a much stiffer design versus a two-piece caliper.
Yeah.
And that's throughout our line, whether it's a 4-piston or a 2-piston caliper. They're all monoblock calipers.
Now you spoke a lot about heat. I mean, that's really the name of the game, one of the main criteria as far as controlling your braking, right? So what's that about? I mean, just for people that don't know so much about these things, basically as the rotor heats up, as these different elements heat up, you have less control over the brakes, basically.
Yeah,
right?
You know, heat is your friend and heat is your enemy. You need a certain amount of heat to produce the right amount of friction.
Okay.
Once you get into that heat window, that's what we want to make as wide as possible, your heat threshold. So at some point, you're going to get into the hottest part of the window and you start getting what people term fade.
Yep.
And that's when the heat surpasses the ability of the pad and the rotor to keep friction. And you still will have lever, but you won't have friction, so you'll have to pull harder and harder and harder on the lever blade.
Right.
The friction continues to go away. The pads accelerate wear exponentially at that point.
Yeah, yeah.
So, you know, a half-horn pad is not 50% less efficient. It's about 300% less efficient.
Wow.
So
there's less mass there.
Exactly. It's all these things matter.
Yeah.
So some people want to throw in a different rotor brand or aftermarket, different pads or whatever. All that's part of the equation that we test.
Right.
That's the same for all of my competitors.
Yeah. Yeah.
So it's always important to ideally stick with OE's pads and rotor for those reasons.
Yeah. And there's different compounds and different, I mean, you were showing this rotor here, and I know you have this new design, which I'd love you to show that. Now this is a two-piece design, right?
This is our newest rotor. It's an e-bike optimized design.
Yeah.
Both of these rotors are. We're looking for more mass, so more heat stability again. In this particular case, this is called a semi-floating rotor. Really, it's a full floating rotor, but instead of it being able to move under my hand, we use these spring washers that keep it from rattling.
Okay.
But the idea is the part where friction occurs, it allows this to be separate from the carrier, and this part can expand and contract without affecting the trueness of the rotor, and it'll stay true longer.
Right.
So,
because basically when it comes out of true, that's quite often where you're going to hear the noise, and it might not be as effective at that point as well.
Right, for sure. And then
you're going to wear the pads unevenly.
You'll continue to generate heat if it's touching, if it's dragging. So
even when you're not actually braking because of that. Yeah.
Exactly. So the truer the rotor stays, the wider the heat window again, the heat threshold. So yeah, a couple new rotors. This is also a new rotor, and you can see the mass of the rotor is quite a lot. This not only provides more heat control, but it's a really stiff rotor also.
Yeah.
And this helps for ambient noises.
Right.
A rotor can be a very acoustic thing. It's like a chance for this to resonate and vibrate.
Sure.
So the stiffer the rotor, the less that's going to happen.
Right.
So we're addressing some noises here. We also have a brand new pad that is e-bike specific, e-bike optimized to deal with the weights, to deal with these resonations that with an e-bike versus a mountain bike, because it's heavier and has more power, it requires more clamping power.
Yeah.
More power than typically you see on a mountain bike.
Right.
So that's where the one-piece caliper comes into play.
No flex there.
Yes, exactly. A stiffer caliper, a stiffer rotor.
Right.
It all is part of the equation.
And this is a little unique, this rotor as well. If you notice, normally you just have these kind of 6 holes here.
Right.
But you have these extra holes, and this is something specific to e-bikes as well. It's a new kind of development.
It's true. This is, these 3 holes are for the mounting of the Bosch ABS ring. So that's what that's for, and this is for a magnet for a speed sensor.
Right.
Either a speed sensor for an e-bike or a speed sensor for a speedometer.
Right, and we're starting to see that more and more integrated in some of the OEs where they'll put this on the rear dropouts, put it inside the rear dropouts to just have that more integrated design, less likely to hit on something.
Exactly.
And I think it's actually more effective, or just the specification, the tolerance of that speed is a little bit better because you're getting more senses per revolution.
I think it's a little better protected too.
Right.
And
especially on a mountain bike or something like that where things are getting beat up all the time.
Yeah, I know that was one of our concerns where the speed sensor was positioned the right distance or knocked off.
Right.
So it's a little bit more protective in there, I think.
Yeah.
And I think it, like you're referring to, I think it's a little more accurate.
Sure.
For readouts. And
that's the word I was looking for. It's precise there.
In addition to the one-piece caliper that we make throughout the line, we use a radial master piston, so this piston moves radially as opposed to axially. And this gives you more mechanical leverage.
Yeah.
And it gives you more feel, more modulation as far as the rider input versus the designer of this brake. That's all the physics.
Yes.
The size of the master piston, the sizes of the slaves, the compound of the pads, that's all controlled by the designer.
Yeah.
But here I have control.
Yes.
Because this input takes my input directly into the pressure of the system as opposed to turning that energy. So in that transition, you lose a little communication.
Yeah.
So my communication between my finger and the tire contact patch. Yeah. So is that important? Yeah, I think so, whether it's loose dirt conditions or wet city streets.
Right, especially in an urban environment where you sometimes have unpredictable events and you have to be kind of prepared and controlling things a bit more.
Fresh rain on the city streets is pretty slick, right?
Brings the oil up out of the pavement. It's actually the slickest point when it just comes on because the oil kind of comes out the surface. Something to be mindful of if you haven't known about that before.
For sure, especially the city streets get super slick. This comes from motorcycle racing.
Yeah.
This is not, we did not invent this, we borrowed it.
Right.
We actually borrowed it from our motorcycle radials.
Wow.
That's a radial master.
That thing
cylinder.
is pretty beefy there.
Yeah, it's got a lot of leverage too in that
right,
bar. But,
right, yeah.
So, but yeah, the radial gives you more communication at the contact patch.
And speaking of this, like while we're talking about it, you know, I know we have the ability to adjust the, you know, the position of the lever. Can you talk to like what the ideal position is, one of the lever, and probably also even just like the angle of the
Sure,
lever?
good point. You know, you'll see it range from, you know, all the way down. That's typically a cross-country racer because they're standing up a lot over the front. Right. You'll see downhill racers that are pretty flat because they're off the back
Sitting
of the
back.
saddle.
Yeah,
And
yeah.
So it's all about this. So it's, you know, it's per positioning. Now, the cargo bike, the city bike,
right.
It's more of a comfort. So yeah, you can position that a little more appropriately, you know, to your saddle height.
I found that usually putting it down a little bit is good because one of the things I found is sometimes in a quick reaction, when the lever is up like this, you can actually kind of like hit your fingers on it. But when it's down here, you kind of can react a little bit faster and not. So that was but it's interesting what you spoke about, specifically the position. And I found that, you know, one of my friends that does a lot of tricks and stuff like that. I know he puts his lever really down. He's often up on top of the bars like that. And if the levers were up here, his hands would be in this weird position. So,
you know, Magura has come on the last 2, 3, 4 years with a lot of customization.
Yeah.
Lever blade options, lever length options, adjustable lever blades, pad compounds, rotor options. We have about 5 different rotor options. But that's the beautiful part about bicycles, whether it's an e-bike or a regular bike. It's about customizing and making your riding position perfect for you.
Absolutely.
So we can do that. Fortunately, you know, car we don't have that choice really. We can't have a lot of, you know, we're limited there.
That's true. That's a great point.
It's a really fun point. You know?
Yeah, I agree. Yeah, and now we even have some like design customizations that you have the ability to do, which is really cool.
Colors and many different lever blades. You talk about lever blades. This is a blade that you can add to any of our brakes, and it has an elaborate lever blade positioning here, but right here it has the ability to move this fulcrum. And the more you move it one way, you get less lever blade movement. The more you move it the other way, you get more lever blade movement.
Wow.
You also get less power, more power.
Yeah.
You get less modulation, more modulation.
Wow, just completely adjustable.
And infinitely in between. So, again, more ability and options.
Right.
So, we're trying to appease everybody.
No, that makes sense. I mean, it's great once you really get into it. So, I just wanted to go over a couple more things that kind of come up quite a bit. You know, so this is a quad piston caliper, meaning it's got 2 pistons on this side, 2 on the other. We have some other like dual piston. You got one over here, I guess, or you got one right here.
Here's
a dual piston.
Right.
Now you guys have kind of at all levels of spec, you have both quad piston and dual piston. So it's not always necessarily that quad piston is better than dual piston, but can you speak to a little bit more of the philosophy and design behind that?
In fact, we have a combo 4-piston, 2-piston.
Right.
You see that on some of
the
your
MT4
e-bikes.
and 5, where so the even numbers are usually dual piston, and then the odd numbers are quad piston.
Yeah. So 4 or 5 years ago, we came up with a combo, and we called it moto style. With motorcycles, you see a lot where they'll have either twin calipers up front, twin rotors, and just a small caliper and rotor in the back.
Yeah.
The bicycle, it's the same way. You have all of your stopping power on the front tire, obviously.
Right.
But you still need to control this flywheel in the back.
Yeah.
It's spinning away. If you don't slow it down, it'll continue to drive the bike forward.
Right.
So you need to have feel and control. It still has some effect for slowing, especially the heavier the bike. Cargo bike has a lot of control. A tandem, a lot of braking control.
Sure.
So the power needs to happen where the traction is.
Right.
So we'll put a 4-piston in the front, twin piston in the rear, and you'll have a combo that works perfectly.
Yeah.
So you can get power out of a twin piston by running a larger rotor.
Okay.
You always get about a 20% increase in each step up in size. So a 160 versus a 180 versus a 203, now a 220.
Now 220. I don't want to segue too much, but the 220, this is a new thing for you guys. It's kind of a big deal.
Right.
But I know a lot of people might be like, oh, I got to have the 220 now. You know, I have 203s, but they're not compatible with everything. So what's the deal with that? I mean, what should people be aware of if they're considering the potential of going with a 220?
Yeah, the larger the rotor, the better heat control.
Right.
Also power.
Right.
So like I said, you get more power. With the largest rotor like that, you brought it up earlier, what's your concerns with the fork manufacturer?
Right.
It's a valid point.
Yeah.
So you must check to make sure your fork manufacturer can handle.
And the axle as well, right? I mean, a lot of bikes are being spec'd with through axles, which is generally going to be stronger than a traditional quick release axle. And we have seen under these extreme circumstances, if somebody sometimes will upgrade their brake, it's spec'd with a 180, they'll put a 203 and a very powerful brake, and it might be too powerful for that axle, or even sometimes too powerful for the force and compression of the fork.
Sure, it just completely bottoms the fork.
It just bottoms out the fork, and then you can actually cause damage to the fork and produce a dangerous situation. So important to be mindful of these things and considering these upgrades, but I appreciate you sharing that. So quad piston, this is also kind of a better heat displacement, generally speaking, than a dual piston?
Yeah, great point. The larger the caliper, the better the heat sink.
Okay.
So these 4-piston calipers, say compared to my competitors, which are good brakes, this is larger.
Yeah.
And at first I thought it wasn't so great because it wasn't as sexy looking.
Yeah.
But in all actuality, it's first and foremost function.
Yeah, that's it.
So it's, like I said, the rotor is your radiator, your caliper is your heat sink.
Right.
And the condition of the pads are important too for that equation. But its advantage of a 4-piston over a twin piston is, it's a better able to deal with intensive heats.
Yeah.
So a heavy laden cargo bike in San Francisco or somewhere where it's
really
a lot of
hilly,
steeps, it's a good option.
Excellent. And so the other thing we talked about briefly is pad compounds.
Yes.
So you have this new pad compound on this brake, which we mentioned, by the way. So this is a new brake that you guys are releasing. But for a lot of the bikes that are on the market today, this is basically the MT5 with some kind of modifications, which somebody could potentially do. Put these different rotors, different pads, and that sort of thing, right?
Easily.
So which I think that might be more applicable to the current market, but this might something we might see more on future bikes.
This will be really, we'll want to see this come as OEM on an e-bike.
Right.
But in reality, this is an MT5.
Yeah.
With different graphics and specific now new e-bike specific optimized rotors and brake pads. So we have 4 different compounds now.
Yeah.
Race, performance, comfort, and now S. And S is for e-bikes specifically. The idea is they bed in quicker.
Yeah.
They're more quiet. And they'll last longer.
Yeah.
So, with an e-bike, you're generating heat more often. Heat will wear. Heat is what really accelerates pad wear.
Yeah.
So, when the pad's half worn, it's less able to deal with heat. That remainder of that pad's not going to last very long if you're working it.
Right.
A downhill bicycle situation or maybe a heavy laden cargo bike.
Is that something that you generally find more like metal or organic compounds?
Great question. Yeah, we use all organic base in all of our pads.
Yeah.
And then we vary the abrasive content. And yes, we'll use some metal, brass, but we use a lot of Kevlar and aramid fibers and things that create friction without without propagating or without passing the heat on through the pad into the piston, into the fluid.
Yeah.
So we say our pads are organic.
Okay.
And that's because the main medium is rubber, basically.
Got it. Yeah.
It's a hard rubber with this. The idea is to suspend the metal and not touch it. Ideally, it's hardens in, it's not touching, so it doesn't transfer that heat as easily. So
cool.
yeah, so we would really never suggest putting a centered pad. A centered pad is metal upon metal fused together. It has a good friction initial, it has high wear, it transfers the heat rather rapidly. Mm-hmm. So no aftermarket pads, please.
Right, okay.
You know, you have to do what you have to do, but
and then now you guys have many, I mean, you have added this new option of the S, which is e-bike specific.
Right.
So would you advise most people to use those on e-bikes? If you know, as we're replacing bikes for our customers and that sort of thing, go with the S. Is there any circumstances where somebody might want to consider some of the other compounds for their e-bike, whether it be a cargo bike or
sure. You know, we have a lot of racers now. You know, we have more and more mountain bike racing coming on. So yeah, you might want more bite.
Okay.
The performance pads that come typically with the brakes are really the best all around.
Okay.
Once you go beyond that with the higher friction, say race pads, you're going to get more noise.
Right.
It's more friction. It's more material, metal upon metal.
Yeah.
If you pay attention to motorcycle racing or auto racing, they have high centered metallic pads. Man, you can hear those brakes.
Yeah, for sure.
When they pull into the paddock, the winner circle, you hear this.
Yeah.
But they don't care.
Right. They work, and that's what's important. And they work under heavy load, which is really important. Yeah.
We also make a 3-finger lever blade.
Right.
So what's vogue is short blades.
Yeah.
They're great. But the shorter the blade you go, the less communication, the less modulation, the less ability to customize your cockpit too.
Sure.
So if you're trying to add a dropper post or
you can't push the lever out like if you wanted to. Sometimes you're putting other things, especially with the e-bike, you have your controller here, you know, thumbcat controller, sometimes a shifter, or whatever the case may be, with a really short lever there. If you push this out, then all of a sudden it doesn't work so well.
So we have ball end and non-ball end long lever blades.
In Europe, that's required for speed bikes, I think, right? The ball ends. We don't have these very specific regulations so much in the US, but in Europe, and actually a lot of these regulations, like the e-bike taillights now, right? So that's something that you guys are doing really well, and actually for us, all the Reese and Mueller bikes come spec'd with e-bike taillights.
Right.
Because that's a standard in Europe, they just carry it over.
So yeah, this is a ball end with a switch in it that can kill the motor or work a brake light.
Right.
The ball end comes from DOT, well, not in the US, yes in the US, but in Europe, like you said. The idea behind that is if you fall, it doesn't.
It's a blunt surface there.
So, but we make it with and without.
Right.
And this is indicative of the 3-finger or 4-finger lever blade I was talking about, the lengthwise. But yeah, it enables you to make a bit more adjustments in the cockpit.
Excellent. Yeah. This kind of shows all the different versions you guys have, starting with the MT2 going up to
MT2, the race line, which is our old historic color that's been really popular. MT8. This is part of one of our combo trail sports I was trying to describe earlier, with a 4-piston front and a twin-piston rear. And then the MT5 and the MT7.
Yeah. And then these are all swappable now, which is pretty exciting. I think a lot of people might like that, you know, ability to put in some custom colors on your calipers, or even you can customize even the mounts up here as well. You can do a different color here.
Yes, we have all.
Let's just show the colors there.
This is just a few of the colors that you can,
So
in carbon also.
bikes are fun, you know. You should kind of
Yeah, absolutely.
have some fun with it, make it
It's
your
still
own.
fun.
Why not, right?
Still very fun.
So-
This is a neat thing that we came up with for e-bikes. This
Oh
is
yeah, I've seen this actually on some of our new bikes now.
So you've got the ability to,
Oh, it makes it easier to hide the cabling, I guess.
yeah, route the
right?
line
Yeah.
differently. We also have a 90 degree that comes out and goes straight
Right
to
into
bar.
into the bar.
Into the bar.
Wow. Yeah.
So it's just a lot of options that we provide that allow you to customize your brake. We have over here a little bit more display. And here's another lever blade this is the Loic Bruni, who's a famous downhill racer.
Yeah.
It's a specific shape. It's longer than the one finger. It's shaped totally different. So we've got, I think, 5 different lever blades to choose from.
Wow. That's really great.
An HC3.
Yeah. Well, I really appreciate you taking us through everything. The one other thing I just wanted to talk about just briefly, what are any like kind of quick tips that you think people should be aware of? Maybe like bedding in their brakes when they're brand new. What should people consider? What should people avoid doing? And
Great question.
Yeah.
Yeah, you know, officially bedding in the brakes from Magura, Germany factory is 30 stops per brake.
Yeah.
That not only, heat cycles the pad to finalize its cooking process. It's not cooking, but curing process.
Right.
So in other words, if you were to take a downhill bike and go straight to the top of the mountain on fresh pads and burn them hard, you're potentially making them too hard or even brittle.
Right.
Versus this more elaborate, proper bedding in procedure.
It's like a heat treating
Absolutely.
system. Yeah.
It's absolutely finalizing the curing process. That's one reason. The other good reason is because the holes in the rotor actually shave and cut those pads. And what I'm talking about is they cut them into the final perfect alignment.
Yeah.
Mounts on bicycles and forks are very close, but
Right.
they're not perfect.
Right.
They're not perfect. So unless you go to the length of facing your brake tab mounting on the fork and frame, which is a tool that fits in the dropout and hand faces and makes them perfect, well then the braking process, the rotor is shaving and cutting those pads, making that alignment perfect.
Right.
So, and when you asked about the proper bed in, some people want to accelerate that. Let's say you don't live in a mountainous area. So it takes a while to shave these pads into perfect alignment. They want to throw liquids in there. They want to throw sand. I've even heard of Coca-Cola.
Oh, wow.
Don't do any of that.
Yeah.
Especially the Coca-Cola, because that's syrup and sugar.
Right.
You're adding to this mix and you're embedding into the pad.
Yeah.
For sure, you're not creating a great scenario. The water thing, it can work, but you're throwing water on a heat real hot and you're creating basically steam.
Right.
So, people are going to do what they want to do ultimately, but the proper is
we're not advising
30 stops.
Yeah.
30 stops. You're curing the
And
pad.
when we say 30 stops, are we going up to a certain speed, stopping at a rapid rate, stopping generally more gradually, right?
Yeah, absolutely. There's no real hard science to it. You don't get up to 30 miles an hour and go to all.
But you don't want to do a real hard stops in the beginning, generally speaking, though, right? You want to do more gradual, be kind of a little bit easier on them to build that up.
You're just trying to heat cycle it 30 times,
right?
Without overheating it.
Yeah, yeah.
That's the main thing.
Great. And any other thing you think that like people should just be aware of or avoid, like things that you feel like come up all the time, and like one of the things, for example, I know we were touching the rotor before, but that's one of those things where the grease or oil from your fingers can actually contaminate the rotor and pads, right? So
yeah,
like that.
Again, the rotor's holes are trying to take care of this.
Yeah.
You're going to throw up stuff from the ground
Sure.
and get on the rotor. But those holes are trying to resurface the pad every time you apply the brake.
Right.
If you notice, the holes are sharp.
Yes.
So they're designed to shear.
Yeah.
Those holes are not real, they're not for cooling.
Yeah.
They're to lighten the rotor and to shave the pads.
Wow, yeah.
If you had a solid rotor, your pads would last a lot longer.
Yeah.
Automobiles typically, no holes.
Right, right.
And how long do your pads
Yeah.
last?
Except for the race ones, that's what you generally
Except
see,
for
right?
the race
Yeah.
ones.
Yeah.
And so with the race ones, they're not worrying about endurance and durability.
Yeah.
They just want it to
Right.
have the right friction all the time. So the
Yeah.
holes help.
Yeah. And use the whole pad, because you might get in a scenario if it's not constantly shaving and keeping that flat, you might not be using the whole pad necessarily.
Well, exactly. If the alignment is not good, if the
Right.
caliper is off, you're hitting only 50% of the pad
Right.
until you've worn it.
Yeah.
So yeah, our positioning of the caliper, if the
Yeah.
caliper is up a little too high, you're missing part of the pad,
Right.
contact pad. So
Wow.
little details, but
Yeah.
the rotors are very important.
Fluid. is
Okay,
one
but
thing,
you
right?
said
Yeah.
one thing, your
Yeah.
hands.
Yeah.
So as long as your hands are not filthy,
Right.
sweaty,
Yeah.
you're okay.
You're generally okay.
You
It
can
might be,
do a good
yeah.
job. It can still do a good job.
Yeah.
It's not so critical. Just make
Right.
sure your hands aren't oily or sweaty.
The oil, yeah. Okay, cool. Yeah. Fluid, and basically we
Yeah.
talked about this a little bit before, like use like what the OE specs. Don't try to make up your own concoction of putting
Yeah.
baby oil in there
Right,
or
right,
whatever
sure,
the case
sure,
may be.
yeah, right.
Especially with you guys use your own fluid, the royal blood, as
Yeah.
opposed to, some of the other companies use mineral oil.
Yeah.
Or,
Well, our royal blood is mineral.
yeah.
It's a mineral base versus a dot fluid, which is a glycol base. So the main advantage of a mineral-based fluid is that it never attracts moisture.
Right.
So it never goes bad.
Wow.
I know that's a big statement. I can't
Yeah.
officially say that.
Sure, yeah.
But it
Well, we'll just cover
lasts-
this up. And
It lasts a very long time.
Yeah.
And its performance really
Yeah.
degrades very, very slightly over time.
Yeah.
I get situations with our old rim brakes or our hydraulic clutches that use mineral-based fluids 15, 20 years.
Right, wow.
15 or
Just
20
sealed
years.
up, people are not touching it.
Exactly, exactly. Whereas a dot fluid, there's a specific formula. You can look it up, even on
Right.
Wikipedia. It's 4% a year
Yeah.
degradation, depending on where you live. It's a high humidity area.
It's going to go
worse,
faster.
yes.
Yeah.
And that moisture enters the system through the seals, through
Right.
the juncture of the line, basically through an osmotic type or osmosis type of scenario. So
Yeah.
that's why mineral-based fluid is superior in many ways.
Yeah.
Sure, it doesn't have as high a boiling
Okay.
temperature. Ours boils at 358 degrees Fahrenheit, but that's well within any bicycle, any e-bike's temperature ranges.
Yeah. Wow. This was like super informative. I really appreciate you taking the time with us, because
That's our pleasure.
I hope that you guys enjoy this. I know it was a bit of a long one, but I think this is like a really great crash course on hydraulic disc brakes and Magura in general. And most of the bikes that we sell in the shop use your brakes, and so it's
I'm thankful for
it's
that.
because we do mostly e-bikes and we do quality, and you guys are kind of the leader in that space. So
We try real hard.
great to be working with you. Great to see you again, Jude.
Thank you, Chris.
I
My
really
pleasure.
appreciate your time.
Thank you for your time.
Yeah, thank you so
my
much.
friend. Yeah.
All right, we'll see you soon.
Thank you.